Good morning, everybody. Their second assignment is out. If you haven't programmed in Java before, you won't be able to start the second assignment unless you look ahead in the lectures, a couple of lectures. So the second assignment has you create some actual objects. Has you create classes where you make objects. We haven't actually gotten to that part in the course yet. And so you can hold off on starting the assignment if you've never programmed in Java before. If you've programmed in Java before, this assignment should be relatively straightforward. Even if you haven't programmed in Java before, if you look ahead to the creating class, if you look ahead a few lectures to where you start to make classes that are used to create objects, I think you'll figure things out pretty quickly. It's not a particularly hard assignment, but it's just there to get people who haven't programmed in Java before used to creating classes and making objects with those classes. There are some typos on the assignment, I've been told. I will try to fix those, assuming I remember, sometime later today. All right, so I guess we'll start this lecture. So this lecture is about Java lists. So it's more about using existing classes than it is on creating your own classes. So we've seen a Java array, right? And we've seen that Java arrays, while their syntax looks similar to using a Python list, the functionality of a Java array is very different than a Python list. If you need something that behaves like a Python list, you need to use one of the list types that Java provides. One of the big differences between Java and Python is that Java lets you pick what kind of list you want, right? And so there's many different ways to implement a list. We're going to, in this course, we should get around to implementing a list in two different ways. And you'll see both of those as we progress through the course. For now, we're going to use the Java standard library list classes. You have to pick between several different types. Usually, you're only picking between two types, and most of the time, you're only really picking one type. So the type that you normally want to use is the class called ArrayList, right? So that's found in the class Java util. That's found in the package java.util. If you click on that link there, that'll take you to the documentation. Now, what you have to remember, especially if you're new to Java, right, is that this thing's called ArrayList, but you have to remember it's not an array, right? Syntactically, it's very different. The behavior of an array list is very different from an array, right? And similarly, an array is not an array list, right? These two things are not really interchangeable. That's not exactly true. You can't really use an array where you would want to use an array list, right? You can almost always use an array list where you want to use an array, right? So the array list provides much more functionality than a Java array. You have to make sure that you don't confuse the two, right? Especially on a quiz, right? When you're programming in Eclipse or whatever your favorite IDE is, normally the IDE corrects you when you try to use the thing, right? So for example, in Eclipse, let me close that. Right. If I try to make, I'm going to make an array list here. Don't worry about if what I write looks weird. I'm going to explain all this in a moment. So list t equals new. Okay, so there I've made an array list object, right? When you're programming in Eclipse, right, one of the problems with programming in Eclipse as a new programmer is that Eclipse tells you if what you're doing is incorrect, right? And so Eclipse makes for a programmer, Eclipse makes your life, or tries to make your life a lot easier, right? You don't have to remember what is the exact syntax for using this thing, right? If I use the wrong syntax, Eclipse will tell me, right? When you're on a test, no one's going to tell you that you're using the wrong syntax, right? You're going to write down whatever you write down, and then you're going to go back to your test, and it's either going to be, well, hopefully right, but it could be wrong if you confuse array lists and arrays. So if I try to use this thing like an array, right, Eclipse immediately flags that as an error, right? And it tells you the type of expression must be an array, but the type is actually an array list, right? And so you know right away that you're doing something wrong. right? So you have to remember that these things are not, arrays and array lists are completely different things, right? The way you use them looks very different. Don't confuse the two, especially on a quiz or a test. All right, so one of the big differences between Java and Python is that Java has these things called generic classes. The Java lists classes are all examples of these kinds of classes, right? So they're all what are called generic classes. In a generic class, the programmer is allowed to specify information about the type or types that the class will use, right? And so if you make a list in Java, one of the pieces of information that the programmer must provide is what type of element is going to be stored in this list, right? And that's very different than in Python. So in Python, you can put whatever you want into an existing list, right? You can put an integer in, then you can put a date, and then you can put a string, and then you can put another list, and so on and so on and so on, right? Python doesn't care. Java cares. In Java, a list is made up of exactly one type of element, right? And so you can make a list of integer, you can put ints into that list. Right? You make a list of strings, you can put strings into that list, right? But you can't put integers into a list of strings. You can't put strings into a list of integer. So in these generic types, there's this funny angled bracket notation that you need to use, right? The element type goes inside inside of these angled brackets. Remember, you only use this notation when you're working with the generic classes, right? So with things like lists, and I guess tomorrow and maybe Thursday, sorry, maybe Friday, you'll also see sets and maps, right? These are all examples of generic types. Okay, so here's how you make this is the old way of making an array list of strings, right? So the type is big A, array, big L list, right? Now you have the angled brackets, right? And inside the angled brackets, that's the element type, right? So that declares the type array list of string. Right? My variable is called t. Now, array lists, these are reference types. So to make an object of type array list, you use new, right? And then you call a constructor, right? So the name of the constructor, remember, is always the name of the class, is same as the name of the class, right? So new array list, and then the old way of creating the object is to declare the type here again, right? So I'm going to say string again, even though I set it on the left-hand side. Right? And then round bracket, so here we're calling the no argument constructor. So in the more modern way of using these classes is that on the right-hand side, so when you make the object, you do not require the element type inside the angled brackets. You still should use the angled brackets, right? But it's not required anymore. So in Eclipse, here's an example here where I made an array list of integer. Let me get rid of that line there. Right? If you want to, you can put the integer over here. Right? The compiler certainly doesn't mind if you do that. Right? In any version of Java greater than 7, you don't need the element type on the right-hand side of the assignment operator if you have the element type already declared on the left-hand side. Right? Now, you can't flip it around. So what you can't do is put in integer here and then remove the integer on the other side. So if you try to do that, you're going to get, now notice, it is an error here, right? So you'll get an error if you flip it, if you omit the element type on the left-hand side. I guess there's one more thing I should tell you about. Well, I'm hesitant to tell you about this, right? You can, in fact, leave out the generic type altogether, right? So that in Eclipse doesn't say that this is an error, right? So notice that it's not red, it's actually in orange or yellow. If you hover over it, right, it will warn you that you're doing something that you probably shouldn't be doing, right? It says that array list is a raw type. References to generic type array list E should be parameterized, right? So it's indicating to you that you really should include the angled brackets and the element type here. If you don't, it still appears to work, right? So don't forget, always put the angled brackets in when you're using the generic types. Right? There is an explanation for why this works. I'll probably tell you what that is a lecture or two down the road. Okay, so there's one of the other funny things about Java, not just Java lists, but any generic type. You cannot create a list or a collection where the element type is primitive. Sorry, that D is a typo. This has been in this slide for years now. I've never fixed it. So just ignore the D, right? So you can't make an array list of int, right? Which is weird, right? Because you'd think, well, I want a list of int, right? How come I can't make a list of int, right? And so this is a limitation of the Java's generic type mechanism, right? The limitation comes because, or appears because these generic types were added into the language relatively late, right? So they weren't designed into the language on day one. So they had to retrofit them into the language, and when they tried to, when they fit them into the language, one of the limitations was that you couldn't write something like that. So they had to, obviously you have to fix this problem because this is unacceptable, right? And so the solution that the Java language designers came up with is to create a class, or a reference type, that corresponds to every primitive type. And these are called the wrapper classes. Right. So for every primitive type, so Boolean, for example, there is a corresponding reference type that behaves more or less the same as the primitive type. Right. So little b Boolean, the wrapper class is big B Boolean. Right. Little c car, its wrapper type is big C character. Right. Why is it inconsistent with Boolean and byte and short? I don't know. Right. They decided to use character instead of big C character instead of big C car. The same is true with int, right? Little I int, big I integer. If you want a list of, if you want a list of doubles, then you make a list of big D double. So the wrapper classes get some special treatment from the compiler. In particular, you can usually, or almost always, when you are using a wrapper type, you can convert it to its corresponding primitive type and vice versa. So for example, here I have an int I, and I set the value of I to 1. Right, now on the next line, I make an integer object called j, and I set its value equal to I. Right? I is an int. Right? So this is very unusual. You can't normally do this in Java. You can't normally assign a primitive value to a reference type. Right? But the compiler lets you do this here. Right? And so this is called auto boxing. So what the compiler does here is it takes that int, right, the value of I, converts it to an integer object, and stores a reference to that object in j. Right? You can also go the other way around. So if I have an int k and I would like to assign it the value that's stored in j, right, I can write k equals j like that, and that's called auto unboxing. So the compiler takes the big I integer object here, extracts its value, which is 1, and then stores the value 1 in the k. Right? So the compiler will attempt to automatically convert between the wrapper type and its corresponding primitive type, right, and vice versa. So if you want a list of primitive type, you just make a list of the corresponding wrapper type. Right? If I would like a list of int, I make an array list of integer. Right? Notice that the right-hand side is always the same, right? So whatever you write on the right-hand side never changes, right? Regardless of what's on the left-hand side. Right? Array, if you want a list of little d double values, then you make an array list of capital D double values. Right? And if you want a list of car, you make a list of big C character instead. So when you do this sort of thing, you almost always get the desired behavior. Right? So for example, I can make an array list of integer called t, and now I'd like to add an element to the list, so that method is called add. Right? Now remember, this is a list of integers, so I really should be adding references to integer objects to the list. Right? But here I can add in the int value 100. Right? And this works just fine. Right? The compiler takes the 100, converts it to an integer object, and stores a reference to the integer object in the list t. Right? Similarly, if you want to take an element out, or you want to get the value of an element in the list and store it in an int, that's fine. Right? So tget0, that returns a reference to the first element in the list. Right? That's a reference to an integer object. But you can store that in the primitive type first. The compiler takes that integer object here, extracts its value, and stores the value in first. Right? So there's an auto box right there, and there's an example of an auto unbox. So yeah, there's only one situation that I'm aware of where this doesn't do what you want it to do. Right? So again, here's my list of integers called t. Right? If you look in the class array list, or so if you look at its documentation, which is here, right? If you look at the remove method, you'll see that there's two. And this is where the problem occurs. Right? So the first version of remove takes in an index. Right? So a list is an indexed collection, right? Similar to an array list or a Python list. If you call remove and pass in an int, the compiler thinks that you want to remove the element at the specified index. Right? If you want to remove an element by its value, so for example, I'd like to remove the string hello from this list, right? You want the second version of the method. Right, this version of the method takes in something called big O object and lets you remove anything that's equal to that object from the list. Right, we'll talk about big O object in a lecture coming up. So the problem here is, right, suppose I add a bunch of elements to the list, right, and I realize, hey, I want to take out the element whose value is 100. So you call remove, passing in the value 100. Right. You have to remember that that's going to call the version of remove that assumes that the 100 is an index, right? So it's not going to remove the element whose value is 100 from the list. It's going to remove the 101st element from the list, which may not be what you want it to do, right? If you really want to remove the element whose value is 100, right, you have to pass in an integer object whose value is 100 here. So that's the one exception that I know of where this auto boxing and unboxing doesn't work with lists. If you really want to remove the element whose value is 100, right, you need to make an integer object whose value is 100. So the method value of in the integer class does exactly that, right? It returns the integer object whose value is 100. If you wanted to, you could call a constructor here as well. So you could write tremove new integer 100. Right? Either one is fine. So this is slightly awkward, but it's the only exception that I know of where you have to watch out, where the auto boxing and unboxing doesn't work for you. Please be quiet. Okay, so the assumption here is that, oh wait, I have the wrong, sorry, this is the CMPE version of the slide. Sorry, just give me a second to download the CISC. Give me a second to download the CISC 124 version of the slides, because the CISC 120 version of the slides has the Python code in it. Sorry about that. Oh, did I miss that lecture? Oh, I did miss that lecture. I'm sorry. Give me a minute while I jump into here. There's not much in that lecture. All right, so give me let me complete this slide and then we'll come back to this.
Is it enough for the quick one?
Okay. Oh, wait. Is this the, did I not change? Oh, here it is. Sorry, here we go. All right, so the assumption here is that you know Python. Right, and so this slide here summarizes a lot of the, I guess, fundamental methods, or fundamental methods and functions from Python, and their equivalents in Java. Right, so in Python, if you want to make an empty list, you just write t equals square bracket, square bracket. Right, in Java, if you want a list of, we're going to assume you have making a list of strings here. So if you want an array list of strings, right, you write array list. String, new array list, right? So call a constructor. In Python, if you want to test if the list is empty, you just write if t. Right? In Java, you have to call a method specifically, right? So you must say if t is empty. So the isEmpty method tests if a list is empty or not. If you want the length of any sequence in Python, you use the function len. Right? In Java, you have to call a method belonging to the list, to array list. Right? So that method is called size. Right? Now again, that's another difference between Java lists and array lists and Java arrays. Right? With an array, if you want the length of the array, right, it's dot length, no round brackets, right? Because it's not a method, it's a field. Right? If you want the number of elements in a list, it's the size method, right? So dot size, round bracket, round bracket. To add something to the end of a Python list, it's the append method, right? The add method is the corresponding method in Java, right? So t.add adds to the end of the list. Where's insertion? Oh, I didn't show you insertion. Now, one of the odd parts in Java is that if you want to insert into the middle of the list, the method is also called add. The methods in Java, the choice of method names in Java is not great. So the other version of add, you also pass in an index that inserts into the array at the specified index. That's getting an element from a Python list, right? Looks a lot like getting an element from a Java array, right? You can't use the square bracket notation with array lists, right? You must call the get method, right? So get, pass in an index, right? Again, remember there's no negative indexing in Java, right? For assignment, again, in Python, you can just use the square brackets. In Java, you have to call the method called set, right? So set the element at that index with that value or to that value, right? It replaces the existing element in the array, in the array list, right? And so this is another confusing thing for people new to Java, right? Suppose you make an empty list up here, and you say, okay, I want to put the string goodbye into the list, right? And so the temptation here is to treat this as though it were an array. So in an array, the elements already exist, right? In a list, that's not the case. So if you make the empty list here and then call set 0, right, you'll get an exception, right? The compiler, when you run the program, you'll get an error. Set replaces an existing element, right? So it replaces the element at index 0. If you make an empty list, there is no element at index 0, right? So set will fail. If you want to add an element to a list, the method is add, right? So set does not add an element to the list, right? It replaces an existing element. Python, you can use in to determine whether or not a value is in a sequence, right? Java, you must call the method contains to determine if value is in the list. Right? If you want to add all the elements from another list to the list T in Python, the method is called extend, right? If you would like to add all the elements from another list in Java, the method is called add all. Right? Pop removes an element, pop removes the element at the specified index from the list T in Python. Right? In Java, the method is called remove. Right? If you call remove in Python, that removes an element by its value. Right? So it searches the list T for something equal to elem. Right? If it finds an element equal to elem, it removes the first one, right? And then stops. So remove elem in Java removes the element equal to elem, right? It removes the first element in the list that's equal to elem from T. Right? There's a Python slice. Right? The equivalent method in Java is sublist, right? And the indexing works the same way, right? So the sublist of T from that starting index up to, but not including that stopping index, is returned by the sublist method here. Right? So this gives you the part of the list T and lets you store that or use that as though it were another list. Right? When you modify the sublist, you also modify the original list. Right? So if you use U to, I don't know, remove an element from U, that also removes the corresponding element from T. To copy a list in Python, you can use copy. You can also create a slice, right, of the entire list. Right? In Java, you just call the copy constructor. Right? And so you can make a new list U, right? call the constructor, and pass in the list that you want to copy, right? And that produces a new independent copy of the list T, right? If you modify U, T doesn't change, right? If you modify T, U doesn't change. The elements in U and T, though, they're the same elements. So if you change one of the elements in T, so if you modify one of the elements in T by calling a method, right, that modifies the corresponding element in U. Right. Count in Python counts the number of occurrences of that string in that list. Right. There is no count or corresponding method in Java. Instead, you have to use a separate class to provide this functionality. So that class is called collections, big C, little s at the end. Right? So the class Java util collections contains a bunch of static methods that operate on lists. Right? Frequency is one of those methods. Right? It counts the number of times that string appears in that list. Right? To reverse a list, you can call reverse in Python. In Java, again, there is no reverse method built into the list class itself. Right? So you have to use collections and call reverse to reverse the list T. Right? Sorting a list in Python. So there's a few different ways to do it. Right? So there's a sort function, but there's also a sort method. Right? So t.sort sorts the list T, changing the order of the elements in T. Right? In Java, you can use the collections class to sort the list, or you can ask the list itself to sort itself. Right? Now the funny thing is, you have to pass in this value null, at least for the time being. Right? So the object or the reference that you're passing in here, that's an object that knows how to compare two elements in the list. Right? So in other words, it knows how to compute less than, greater than, or equal to for the elements in the list. If you pass in null, then the elements of your list need to know how to compare themselves, right? Which is everything that we're using for the time being. Right? Later on, I might show you, if I remember, I might show you how to create an object that knows how to sort stuff or compare two elements. Right? For now, if you want to sort a list, use collections.sort or call call sort and pass in null. Okay, so let me stop there because I guess I did really miss the lecture and go back to the preceding lecture. There wasn't a ton in that lecture anyway, so hopefully going out of order doesn't cause any confusion. Okay, so this is the creating and using objects lecture. But we've already done or talked about a lot of this stuff in the course. Okay, so almost every Java program is made up of objects. You could write an entire Java program using only primitives, only primitive values, right? On your computer, everything's just ones and zeros. So it's feasible to write a Java program where everything is just some kind of int value. Or some other type, some other primitive type, right? That would be very awkward. It's possible to do. It would be super awkward, and almost every non-trivial Java program is actually going to use objects, and those objects will interact with one another. Right? So remember what an object is. An object is just an instance of a class, right? Objects have information, right? They store data, and they can perform actions usually on the data that they store. Right? And so by using objects, right, it becomes, well, the idea is that it becomes easier to create complicated programs, right? Or programs that do very sophisticated actions. Right? You just create the objects that you require and they talk to one another to perform operations on their values. Right? So objects store information, right? They store the information in variables. So every object has its own variables, right? Those variables are called fields, right, in Java. You might also see the term instance variables, right? Which is just emphasizing the fact that the variable belongs to an instance or an object, right? The most common term that you'll see in Java is field, right? So your fields of your object, they can be primitive types, right? But they can also be reference types. Right? So in other words, you can make an object. Inside that object, there's a reference to an object. Right? Inside that object, there's a reference to an object. Inside that object, there's a reference to an object, and so on, and so on, and so on, and so on. Right? So in other words, you can make new objects that themselves contain a bunch of objects. Right? So the set of values of an object's fields is called the state of an object. Right? So if you have an object that has two ints in it, and the values are 1 and 2, we say that the state of the object is 1 and 2. Right? It's just the state of all of the fields of the object. Okay, so objects perform actions. Those are the methods that the object has. So in Java, when you want to make an object or when you want to use an object in your program, right, you have to make the object. Right? So it gets born or created. Right? Once you've got the object, you can use it, so it has a lifetime. Right? And once you're done with the object, you would like to get rid of the object because it's taking up memory and possibly other resources. So you would like to get rid of the object or destroy it or kill it, right? Have it die. Right? So in Java and in Python, you can control the creation of the object. You can obviously use the object, but you never deal with getting rid of the object. Right? In both languages, removing unused objects is part of the language itself. Right? So whatever controls the running of the program is also responsible for the removal of unused objects. So you don't have to worry about deallocating the memory that an object is using. Right? Whenever you want to make an object, you're always calling new. Right? So we've seen that in previous lectures. You want to make random numbers, you make a new random object. Right? If you wanted to make a string, if you wanted a new string, you could make a new string. Right? And as you've seen earlier in the lecture today, if you want an array list, you make a new array list. Right? New actually does a bunch of things, right? So it allocates memory for the object. Right? It then calls the constructor to initialize the state of the object, and it returns a reference to the newly created object, right? So it actually does a bunch of things. Right? So new is responsible for allocating memory for the object. Right? The constructor is responsible for setting the state of the newly created object. In the notebooks, there is this class called point2. Right? Point2 just represents a two-dimensional point. Right? So it represents a point having an x-coordinate and a y-coordinate. So here you can make a variable of type point2. Right? I would like to make a point2 object, so I use new, and now I call the constructor. Right? And if you look at the slide here, it looks like there's 3 different constructors for this class. Okay, so when you use the first constructor, it turns out that makes the point 0, 0. When you call the second constructor, it looks like that's the x-coordinate of the point, and that's the y-coordinate of the point. So the second constructor lets the user specify the coordinates of their newly created point. Right? Now the third constructor is interesting. Right? It takes in P2. Right? P2 is a point2 reference. Right? And so this constructor here copies the point that was passed to it. Right? So the third constructor makes or initializes a new object whose value is the same as P2. Right? So in other words, you now have the point. You now have 2 copies of the point having coordinates 1 and 0.5. This is the scanner class. I'm never going to ask you to use it, so don't worry about it. The only reason I'm showing this to you is because in many introductory programming courses, a lot of the exercises are write a program that reads the keyboard and does something. You're never going to write a program like that in this course. You're probably never going to write a program like that when you go to program professionally. Right? You almost never do this, right? At least on modern computer. Right? If you want to do this sort of thing, and you would like to read the keyboard on your computer, you can use a scanner object to do this. Right? So again, this is just showing you the using new and calling a constructor. Right? So you make a new scanner object, system.in. It turns out that's the thing that corresponds to your keyboard. Right? And so that reads your keyboard. Right? You can also use a scanner to read the contents of a string. Right? So here's a string: 1 fish, 2 fish, red fish, blue fish. Right? I can create a scanner object that can read the parts of that string. Right? If you go and look at the scanner class documentation, you'll see that there are methods that let you extract a integer or a double or a Boolean from something, right? Or a string from something. So you could, for example, extract the 1, then the fish, then the 2, and then the fish, and so on, and so on, and so on, using a scanner object. Right? Again, I'm never going to have you use a scanner in this course. When you use new, you always call the constructor, right? That's the way it works. So you have to call the constructor because the constructor is the thing that initializes the newly created object. Right? When you call the constructor, it looks exactly like a method call or a function call in Python. Right? So new constructor, round brackets. If there's a constructor that has some parameters, you have to pass in some arguments to the constructor. Right? The Java language is very specific. It says constructors are not methods. They look like methods, right? You use them almost exactly the same as you'd use a method, but they're not methods. Right? So a constructor in particular never returns a value, right? It doesn't even return void. So you're going to see when we get around to making a class that has a constructor in it, right? The constructor will not have a return type beside it. Constructor names always match the name of the class. You have no choice. Right? If you create a constructor and the name doesn't match the class, you end up with a method instead. The purpose of a constructor is to initialize the state of a newly created object, right? So when you make a new object in Java, the idea is that the object should always be created in a usable state, and it should have a well-defined state. Right? The job of the constructor is to make sure that the created object is usable and well-defined. The constructor that has no arguments is not surprisingly called the no-argument constructor. Right? Its purpose is to initialize a newly created object to some well-defined default state. Right? So if the user doesn't know what coordinates they want or doesn't care what coordinates the newly created point is, that's the constructor that you use. Right? Exactly what does it do? Well, you have to go look at the documentation for the class. Right? So for the point2 class, I've decided that the state of the newly created point should be 0, 0. Right? You have to pick something. Right? So when I implemented the point2 class, I decided that it should make the point that's located at the origin. Right? Classes do not have to have a no-argument constructor. Right? So you might be able to write this, but you might not be able to write this. Right? You have to look in the documentation to determine whether or not there is a no-argument constructor. If you look at the ArrayList class, right, and you look at the constructor section up here, right, there is in fact a no-argument constructor. Right? That constructor makes an empty list. Did I miss one? No. That third constructor down here, right, is called the copy constructor. Right? It's called a copy constructor because the argument that you pass in has the exact same type as the class itself, right? Or is the same type as the constructor. Right? So here you're going to pass in a point2 object. Right? The purpose of a copy constructor is to copy an existing point, is to copy the state of an existing point. Right? So that constructor there copies the coordinates of P2 and sets the point P3, or sets the point referred to by P3 to the coordinates of P2. Right? And so that makes the second point, a third point in this case, whose coordinates are 1 and 0.5. Right? The same as the second point. Right? Oops, sorry. Not every class defines a copy constructor. Right? Again, you have to look in the class to determine whether or not there's a copy constructor. Now, somewhat confusingly, if you go and look at the ArrayList class, oh, there it is, right? It doesn't look like there's a copy constructor here. Right? So there doesn't look like there's a constructor that takes in another ArrayList object. Right? That third constructor right there, the thing that takes in a collection, it turns out that's the copy constructor for this class. Right? And so when we talk about inheritance and interfaces, right, it's then that you'll understand that this is in fact a copy constructor. It turns out array lists and lists in general in Java are all instances of this thing called collection. Right? And so it turns out you can pass in whatever collection you want, and this copy constructor will copy that collection. Right? So that's the copy constructor for this class. And finally, you can have all other sorts of constructors, right? Their parameter lists, as long as their parameter lists are all different. right? And so you have another constructor in this class. This one takes in two double values. It sets the coordinates of the points to those two double values, right? The x coordinate gets set to 1, the y coordinate gets set to 0.5. There's a scanner again, right? So again, there's two different calls, there's two different constructors being used here, right? One takes in this thing called system.in. Its exact type is not important, right? The other one takes in a string, right? So classes can and often do have many constructors. Okay, once you've got your object, you would like to use it, right? So the way you use your object is you use your variable name, and you call methods on the object, right? And so the syntax in Java is always the variable name followed by a dot, followed by the method name, followed by whatever arguments you need to pass in, right? So this is exactly the same as if you were using a Python method, right? So the dot here means you would like to call that method belonging to that object, right? Passing in those values to the method. So there's no way for the Java programmer to use an object directly, right? You're always using it via a variable, right? Via a reference of some kind. If the object has publicly available fields, right, then you can access the fields by writing variable name dot field name, right? And so, are we ever going to see an example of this? I'm not sure if we actually see an example of this anywhere. If there are publicly available fields, though, you can access them via the variable name. Okay, so here's an example of using a point, right? So I'm going to make a point whose coordinates are 0.5 and 0.1. Right? I would like to find out what is the x coordinate of the point. So it turns out there's a method called x that returns the x coordinate of the point. Right? So p.x returns the x coordinate of the point referred to by p. Right? So that's going to be 0.5 in this case. Right? Get you in a second. P.y gives you the y coordinate of the point. Right? So p.y, ask the point p for its y coordinate. Right? That's going to be 0.1. Right? I now have the x and y coordinates, so I can now change them to 0.1. So by subtracting 0.1 and adding 0.1 and subtracting 0.1. Right? I would now like to tell p, hey, change your coordinates to the new x and the new y. So it turns out there's another method called x that takes in an x value, right? So that method changes the coordinates of the point to, in this case, 0.6, right? There's another method called y that changes the coordinates of the point to the new y value. So that's going to be 0, right? And similarly, there's a method called set that lets you change both x and y at the same time. Right? So p.set x comma y sets the coordinates of the point to whatever value of x and y. Sorry, you had a question?
Sorry, yeah, I just want to double check. The reason that we use p.x and then the method for it is because that x itself is I'm guessing a private variable?
Yeah, so you don't even know what the names of the variables are that are holding the x and y coordinates. And here's another little program. So if you have the source code for the course, so there's a zip file that contains all of the code for the course in Eclipse. Is it here? And it's not here. Sorry, I don't have it in this workspace. Right? You'll see there's a little program. There's a couple of little programs that move points around. Right? So this one, what do I have here? This one just moves the point back and forth, so it moves it from left to right on the screen. Right? There's another one called bouncing ball, and that makes a point that looks like a ball that bounces up and down on the screen. Right? Again, these aren't super important for this point in the course. They're just examples of creating interesting programs using objects. There's another scanner example if you want to use scanner, and another one. Right? Again, I'm never going to ask you about it. Okay, so when you go to use classes, right, you need to know, well, what can this class do? How do you know what it does? You have to go look at the documentation for the class. Right. All of the standard library classes, you can find that link there takes you to the version 8 documentation for the standard library classes, right? If you want to, you can look up a newer version of the documentation. Alternatively, just type in something into your favorite search engine, right? So Java array list, right? Documentation will probably get you a reasonably good link to the Java array list documentation. Right. Later on in the course, I'm going to show you how to write documentation for the classes that you create, and you'll be able to generate the exact same kind of documentation for your classes. Right, so there is a way for you to generate documentation that looks like this, right, for all of your classes. Java has a standard way of documenting stuff and generating the nice-looking documents for the documentation. All right, so sorry about jumping out of order there. Hopefully that didn't cause any confusion. I guess this is a good place to stop. So in the next lecture, we're going to look at examples of using the list to solve some simple programming problems.